César. César, I've known César for probably over a year now, online now. I mean, seen his videos, blog posts, and we first met because César posted something to me that blew my mind, that you can actually create data quality assertions by prompting a model. And I first didn't understand, take me a while to understand. It was a long time ago. And César then joined our contest and actually did this same thing instead of OpenAI with Ludwig now that he'll talk about. But the most remarkable thing about César is that he was rushing to drive, and I was worried that he'll be driving safely to get here. But now that he is here, César, can you please say a few words about yourself? Welcome.
Thank you so much. It was a bit right on time. Sorry, I don't expect most of the time to arrive right on time, but to have some previous time. But I'm just a friend of mine was kind of awarded, so I kind of had to do two things at the same time. So this was the best we could do. Like uh, 30 minutes in, try to provide some value to all of you and try to share a bit of the journey using Ludwig and just using it to a very particular case. My initial goal was to work. I met Alex when he was working at Great Expectations. And just to give you an overview, I don't know, Alex, if you would like to make me a co-host so I could like also move back and forth. Maybe we do next.
I can just, if you have your slides, I will stop sharing and you can share. Would you like that?
Maybe
Or I can move the slides for you.
maybe yes, just give me 10 seconds so I
Okay.
can open up and share the by the time I think by the time you make me co-host, I will be just ready here. Thing is, from the last time I was sitting in the front of the screen, my computer decided to reboot. So sorry for that. But okay, I am ready to share the screen.
Go for it. Share. And
So
what city are you in, Cesar, right now?
I'm in Madrid.
Okay.
And I was just coming from Italian embassy. So it's like I've been in two countries at the same night. It's very, very interesting way to be. So my initial goal was to work with Great Expectations. I made a joke like, who wrote Great Expectations? Dickens. So I decided to call my project Dickens as the writer that writes Great Expectations. The main idea being
Now I get the joke. I didn't get it before. Now I'm
okay. That's nice. So the main idea, I was working with open data, and the main issue, most of the data you find online is basically a PDF describing the data with English or Spanish or whatever language, plus Jerry files for CSV, Excel files. Maybe this is governments, maybe this is your city, your country. Open data is basically everywhere. Just in Europe, there are 1.6 million data sets. And the main challenge when you are dealing with this amount of data is how do you measure the quality? How do you find out if the tabular data is the same as the one you're having in the PDF? So that was kind of the challenge. And first thing you can imagine is like, okay, I maybe can use some custom Python functions. It doesn't scale really well, as you can imagine, like trying to find out all the different ideas. So there are high-level libraries like Great Expectation or Soda that both are, Great Expectation is Python. Soda has its own checking language, but the main idea is you get this kind of higher level functions that is like expect the column values to be between, and you set the minimum and maximum range, and then you test any column, any row of your data against these expectations, and you either get it to pass or to fail. So by the time I met Alex, I was working in my master thesis on open data quality, and suddenly I just realized that I could ask GPT-4 to evaluate the quality, or maybe even better, maybe I could ask GPT-4 to write for me the Python functions that could evaluate the actual data. So the main idea is, okay, I'm going to get the description from the PDF. I'm going to pass enough information to GPT-4 so it knows about my context, and I'm going to ask it to write the Python code to check this out. So this is kind of the broad level idea that I had. And then by the time I was, oh, I'm moving backwards, sorry. by the time I was like finishing my master's, like then Soda launched this idea of Soda GPT, that is like a GPT that writes quality assertions in its own language. Soda GPT is basically Falcon 7B model, an LLM, open source. And the main idea is they train this just to check for the data quality. So how do they do it? I think you may be familiar with this schema of data quality checks in natural language in one column. This would be your input, and then the expected output on the right-hand side. This is your training data set. So with all this data, they created a LoRa.
So, César, just to clarify for myself, the output is actually the Soda as
Soda
well
checking language.
but it's code, right? It's
It's code. It's code.
Okay.
And so my goal was to produce valid Python code. This is interesting because in my particular case, by the same time, one guy just created a Bird data quality. It was his username. So the idea was the same: put an Excel file, then pass it through GPT-3 or 4, create the rules, and check this out. So in the end, what we are trying to achieve here is to write valid Python code, but valid Python code that is one of the main functions defined by this library. So it's like a subset of the whole schema. It's not, I cannot just check if it's valid Python or not, but I have to verify that whatever I'm producing is kind of the desired output. So main challenges I faced when I was starting this, there was a data set, existing data set I could train from. It was about 250 examples. And I started like with this idea, like get the PDF, run it through my LLM, get the grid expectation output. First thing I realized, Mistral was really poor, like getting what was really nice in terms of getting the expectation, but was really messy with the parameters. So I could not create code that I could execute. Then I said, okay, maybe I could try to fine tune it with the existing data set. But the main challenge, as I started doing an analysis of the existing data set, I just realized that out of the 58 functions available in the library, only 33 were in the dataset. So like half of the functions were never in the training dataset. So I could be, again, like trying to produce code without making any sense. And the dataset was really badly unbalanced. There were like 20 examples for one function, and maybe for other function, there were like 2 different examples. So it wasn't like I could generalize. So I said, okay, it's time to move forward. So what I did was,
clarifying questions, César.
yeah. So sorry.
These functions are like when you apply these functions, it's just then you apply only one of them, right? There's no composition of them. There's no like larger, like more complex interactions between them. It's like one at a time. With
it's like expect this column. There were 2 kind of interactions. One is like kind of column level, but there is also like a table level. So you could say like check this table to have the following columns, and you can pass a set, and you can verify if the tables match your given names. But you could also say for this column, all the dates should be complying with ISO 8601 format.
Perfect. And so the kind of thing that you needed were both the name of the function and the values for the parameters of that function, basically, right?
Yeah, there are kind of unitary operations that you don't combine the columns and the tables for different things. As far as I know, they all have like different data sets. So,
thank you.
So what I did was like, okay, I'm going to create my own synthetic data set. So I created a data set that I release also. I use GPT-4 with a super long prompt. I can share the link for the prompt here also. And I created around 1,000 expectations with even coverage of every single function in the original dataset. This was going to be my fine-tuning dataset. And then what I realized really fast also is I'm not going to be able to evaluate this on the bigger scheme of things. So I also created a prompt so I could get the output of this Dickens LLM I can pass it down to GPT-4, and GPT-4 will evaluate as a Boolean whether the output matches my data quality rules for the expectations. And this is what I use with Ludwig. Maybe it's simpler if I share with you the here the collab file and I share the particular examples, because otherwise I feel like I'm talking in the air.
Actually, yeah, a concrete example would be super useful. Yeah.
Yeah. So I'm going to share this on the chat. So because of the memory constraints, I had to split this into two different notebooks, because otherwise, if I run through the whole thing, it will fail with the non-premium one. So just to give you the overview, this is the instruction. Division name should be either values NSA or start by letter D. And this is kind of the response. This is my baby that wants to go to sleep, so I will be. So this is kind of the response. Spot column values to match regex, like division, NSA, or starts by D. If I go down here, okay, just give me a second. I will bring my baby in. So there's no.
Sure, no worries.
Ven, ven, ven aquí. Ah, estoy hablando, así que no podemos salir. Okay, I think this is going to be.
Hola.
Hello, mira, te dicen hola. ¿Ves aquí? They say you hello,
Hola.
hello. Okay.
Hello, little one.
Okay. So just give me a moment. So this is kind of the evaluation, the performance of the model. I created some kind of golden examples of prompt example, completion example.
Mhm.
And then I fine-tune the model using a regular QLoRa fine-tuning adapter, using this very lame prompt that I'm sharing here. And just did a classical training test split. And how do I evaluate this? Okay, if you go down here, I was like, this is kind of this original instruction in natural language. This is ground truth from my golden file. This is the generated output. On the first time, like you can see, the values for the parameters are not the same, or even the function names are completely hallucinated. Like for example, here, the function is spec column values to be date util parsable, but the generated output is spec column values to match schema date format. It doesn't exist. Looks plausible. Even I think the most expert great expectations could be fooled by some of these hallucinations. So like I was saying, I created a prompt where I was evaluating if the generated output is a valid expectation or not, if validates the data as expected, if it's the same expectation as a ground truth example. I was passing the whole code through this so I could evaluate if I was improving or not my results, doing the fine-tuning. And after doing the fine-tuning, I have to say that the results are much more better, are better tailored to the ground truth. I'm using Zephyr model as the basis, and it usually misses the capitalization. So it's like division, it usually gets into lower caps instead of upper caps. But I also kind of changed the, regarding to what you were talking, Piero, when I entered in, one of the things I made to improve the general responsiveness and overall results was replacing the prompt by, it was like a very crazy prompt. Let me just share with that for a second. This is the fine-tuning only. I will share also the link so you can check it out here. Let me just share it here. I think maybe I'm passing my 10 minutes allotment, so just feel free, Alex, or anyone, just to, if you think I'm taking too much of your time, just let me know.
We're good. To me, it's interesting. I hope it's interesting for everybody. But, I know that you're leading to your much more improved scenario. So kind of.
Yeah, this is where I'm here. First thing, I created this synthetic dataset, dataset generation. It's available here on Hugging Face. So if you want to check it out, maybe I will also copy the link so you can see kind of the pairs and the functions. And the thing is, when I went to here, I tried to combine all the things I made. Un momento. So this is my final prompt. So this is like, here is the complete list of my core expectation included in the Python library with a complete list of all the 58 expectations. I gave it the explicit goal to return a single expectation with the correct parameters based on the instructions. For every input, you will read it, and you will be evaluated on the criteria. So even in the prompt, I'm just passing the message, what will be the criteria for each of these ones. And each one of these criteria will be evaluated as a Boolean, and the final score will be the sum of the individual scores. So the higher the score, the better performance you have.
Perfect.
And I'm giving also like a few short examples of expectations, like input verify that the column income exists, expect column to exist. And I'm kind of passing it all out kind of in the same way, doing the fine tuning. So the main idea was to show up a better performance. As you can see in the second notebook, most of the values are better. Most of the parameters, so it was a try. I think there is still some work to do in terms of, for example, validating. As I was reviewing my synthetic data set, I just realized that GPT-4 for one of the functions always missed our right-hand side on the parameters. Let's see. So there is still work to do to make this like kind of production safe, but I think like it's really interesting to share this as creating the right fine-tuning data plus adjusting the prompt to perform better and then combining them both. I think that by itself is very valuable. See.
This is super cool, Cesar. I think it is amazing, and the fact that you're getting better results with better prompting and better fine-tuning is also great. I think it is amazing. I have a few ideas as suggestions to actually potentially get even better, but I will want to get others people like perspectives first. I think Arnav had something.
I see here Arnav like it may help to include the max sequence length from 48. Yeah. I have to say the input, I just measured this to be under 2K. So the whole
nice.
is around 1.5. So I could have like, I was considering like not really good context length for that, but.
Actually,
yeah,
one observation there is, Arnav, do we have any at least warning when the prompt is longer than the actual max sequence?
Yeah, it'll raise a value. And actually, so two things will happen. I think it raises a warning, and if all your data exceeds it, you'll end up with a training set that has 0 rows, and it'll raise an error at pre-processing.
Right.
So there is a warning that we do log if like input plus prompt is exceeding global max sequence length.
Yeah. So if Cesar was not seeing it, probably it means that it was.
It's fine. Yeah. That's right. Good point.
Yeah. So, by the way, this is super cool. Alex, do we have already like a blog post in the making for this? Because I think it's super cool.
I agree that it's super cool. Cesar, you had a video or you're working on a video for this?
Oh yeah, I did my day was a bit complex. So I did a live streaming this morning in Spanish, like 1 hour long, describing the whole process. Because one of the challenges I think we have in Spanish is that there's not really good content about this. Mm-hmm. So I did a video that was calling how to do fine tuning. She wants to speak with you all also from here. So yeah, I will share the link later on but yeah, we could work in a English version describing the whole process and finding out the flaws in it wasn't flaws, but it wasn't like the ideal perfect data set to start on.
Yeah. Or we can also, help you out with the Spanish one. We don't have Spanish content. It would be super cool to put out some Spanish content. We can definitely collaborate on it. I think both will be amazing, right?
Absolutely.
I actually have a couple ideas or suggestions or things like probably you right-sized the prompt, but maybe by giving you a little bit more space, one additional thing that you can consider doing is for each function to also specify the set of parameters of the signature of that function, because that could potentially help. If it's already in the prompt, then it's easier for the model to learn to copy the name, the exact name for that specific function, and potentially get less confused by it. So that's one idea. And another potential idea to improve it even further could be, I don't know if you saw it, but we added, it's on the Lorax side, not on the Ludwig side, but we added the capability to, at prediction time, specify a schema, which is a pedantic schema. And so maybe if we could manage to define a pedantic schema for the great expectation functions with their parameters, then basically the output could be constrained to only output valid great expectations functions, which potentially could help a lot. Maybe Alex, if you can, maybe you can show like the JSON output blog post for a second, just to give a little bit of a hint of how that looks like.
Also had another idea, like with great expectations, there are lots of expectations, and so this may be conjured up that can be different like schemas, table expectations, column expectations, icon expectations. That was one thing, and I found the blog post. The other I thought I had is that both Soda and great expectations are them in specific languages. Moreover, great expectations is a Python-based domain-specific language. What if we did some experiment on other base models that are potentially better for emitting code, Python code, or maybe even DSLs, and see if the efficacy could be improved even on top of.
Right, that could be also in
So the outlines blog post is there, and it's a very, very, in my opinion, clever way of constraining the output to adhere to, as Pira said, pedantic enforced schema.
I think Seva has also had a comment, right?
Yeah, thank you, Piero. Just a quick feedback, and thank you so much for this presentation. It's exactly type of content I'm really looking for. It's very practical and very good very easy to follow. Thank you for that. Just question on generating synthetic data set. So after César, after you like created this prompt and generated this data set of like 1,000 records to cover all these like 50 functions, how did you decide to stop on like exactly 1,000 records? Why not to go for like 2,000 or 3,000? So what kind of intuition you used here? And for how many epochs did you fine-tune 7 billion model? Just 2, 3 of them. So it's more interesting why you decided to stop on like 1,000 records exactly.
Yes, I'm muting, so I can I like trying to get a lot of the local noise here filter. So the thing is, like, when I was creating this, it was a really practical thing, also related to the context length. But that time, I didn't have access to GPT-4 API, so I was like, what is the maximum number of expectations I can get in the output as a JSON formatted under the regular $20 per month plan? And it was like around 15, 16, depending on the expectation. So I was like, okay, I'm going to create 15 at least for each one of the expectations, so I can cover all them properly. But yeah, I could kindly duplicate this easily. So I also maybe can share the screen again for a second to guide you through the prompt of the synthetic creation of the, maybe you are interested into that. It's kind of super convoluted prompt, but I think it's like quite interesting. It's like, it says like one expectation is a verifier of certain about data. So I'm here giving it more context about the library. The goal in this task is to produce 15 pairs of prompts and completing in JSON format. Usually it's the same thing. Given an input text, you will read information, you will be evaluated on this criteria, This is the simple output I'm giving this. And this is the simple output I'm passing. Given the expectation name, all this information is taken from the grid expectation function definition. I took all of the function in all the docs in the grid expectation function, and then just created a sample output for one of these with a JSON file based to the example I passed then. And then I said, okay, following the given example, generate now 15 pairs for the following expectation. And I will give the input and the documentation for the new function I was trying to provide and create the synthetic data, and then finish with this classical output in JSON format. Prompting like this, I would get every single time 15 expectations. If I try to go for 16, 17, whatever, it will mostly require me to do kind of 2-3 prompts to finish the whole run. So I said, okay, given I'm my time is limited, and the number of calls I can do is around 30 per hour per hour. I have one day to do this manually, like copy paste, run this, copy paste, run that. And I was like, okay, if this works, maybe you could scale it like with this very same prompt. But by that time, I didn't have access to the API. So I was like, try to use whatever is it at hand.
Okay, I see.
GPT-4 is much more better than GPT 3.5 when generating these JSON formatted outputs. I think if I had to do this again, I would try Mistral plus Solama plus JSON mode to make sure I am producing JSON outputs, probably. Or maybe LoRaX, like Alex was sharing in the link. And yeah, Arnav said you can try CodeGemma. Yeah, I think there are so many options, but I have to say this was like 6 months ago. That feels like 15 years ago in AI times. So yeah.
And you manually checked each expectation statement, right? To make sure that it's properly formatted, proper syntax, correct.
No, it's even better. I just, based on what you were saying and based on this idea that Piero was talking about, the pedantic approach, I just tried to, I created a script like Dickens verify that would verify that all the produced code was actual Python code using the AST library. So I ran this data set, ran against my own data set, verified all the functions to see if it was valid code. And this is when I discovered 17 errors in one particular function. This was like producing double brackets in the end. So I could like, okay, I'm going to check if my data set is actual Python code. And then I detected that 15 functions all in this kind of particular expect column quantum values to be between this and that. So yeah, actually, this is what I ended up like discovering, that not all the synthetic data was actual Python functions. I agree that right now, Pydantic is the way to go, and it's simpler, it's more scalable, and to create a tree with the different options wouldn't be that hard, I think.
But back then, I think the use of AST is totally appropriate, and I think that's a great tool to check if something is real Python or not. Thank you so much, César.